Welcome everybody. I will be spending the next 45 minutes trying to share with you an experience that we had for over 20 years at Harbec and the valuable things we learned from it. First of all, what's a Harbec? You just saw some picture there. We were a precision component manufacturer for aerospace, medical, and high industrial uh, type of customers that we had are in the example below. Next slide, please.
Oops, sorry.
So, sustainable manufacturing, what is it and why bother? The US EPA definition for it is sustainable manufacturing is the creation of manufactured products through economically sound processes that minimize negative environmental impact while conserving energy and natural resources. And they go on to list that key benefits are lower resources and production costs, which is basic common sense. If you're using less, you're spending less. Lower regulatory compliance costs. Also, if you're polluting or contaminating or whatever less, you have lower costs for that also. Improved sales and brand recognition. That is yet to be determined. It didn't work out as we had hoped, as quickly as we had hoped, but that was because it's up to the rest of the world to decide whether it's valuable or not. And greater access to financing and capital. We did find some examples of that there, and basically in the form of what they're calling green banks. There are lenders or institutions that are looking for the opportunities um, to finance what would normally be considered unusual projects in the area of sustainability and renewable energy and things like that. Easier employee hiring retention. That's very big, and we grew over the 20 years. It didn't start that way, but over the 20 years, we were able to create a team of people in our company that went from not really understanding it to being very proud of it. And it became one of the greatest attractions to our company for new employees. Next slide, please. What is carbon responsibility? That's pretty basic common sense, but in the United States, as an example, we basically ignore it. We don't acknowledge that there is any kind of global warming, or actually, current administrations even fight against it. So um, there's no direct impact in the United States relative to economics of carbon. We have open dumping of atmospheric trash is allowed in and even encouraged in examples like the coal revitalization that came in the first Trump administration and is echoed now in the second and even worse. European, though, carbon markets are the example for us. They provided us a breath of fresh air and a hope that the world will eventually come to it. And in Asia, carbon market ambitions, there are several Asian economies that have stated intentions to move toward carbon price and carbon traded systems and to compete against Europe and what they have in place. And again, in the United States, carbon dumping is mostly comes from, in manufacturing at least, comes from the electricity generation and from vehicle fuels. Next slide. Our situation is different than yours in Quebec. Energy is ever increasing. Today we sit at, as a small manufacturing company, to give you perspective, we are between 19 and 22 cents a kilowatt hour delivered. There's a big thing in our energy world where the utilities quote what their cost of energy of electricity is per kilowatt hour, but it isn't really that because when they add in all the tariffs and everything else, so the way to really decide what your energy cost is to divide your total monthly kilowatts into the amount of your final bill, and it's always in our area again ranges 19 to 22 cents currently. And all we know about that is that it's going to go higher. It'll never go lower. It never has, and it never will. Your situation is much different. And again, one of the ones that I admired during the years of trying to put something in place, hoping that our country would also come up with something like this, but it hasn't as of yet, or currently at least. So these are examples of what you enjoy. Unfortunately, some of them are even being dampened by our efforts currently by our administration. But at least you still have things like the cap and trade, and you have your industrial carbon pricing for large manufacturers and companies. And but even in that case, your big concern is that you're so dependent on imported oil and gas, and so you need to think of ways too of being able to use less of them and more of the wonderful renewable energy that you're blessed with. Um, One thing we know is that the Trump administration will pass. And our embarrassing situation that we're in right now won't last forever. Um, but carbon situation will. And hopefully we will get back to paying attention to it and considering it important. If carbon remains a priced input and energy costs continue to rise, firms that cut emissions and reduce consumption early secure a structural cost advantage for the next 20 years and more. So it's worthwhile to get in place now. Why adopt superior energy performance, or more clearly, the ISO standard 50001? For us, it was a way to document and to learn, because ISO is not only the standard for less energy per widget forever, but it's also a great teaching entity. So, along with the process of certification of energy slash carbon responsibility, it comes wonderful teaching tools of ideas and methodologies and measurement tools and all of that that lead you to performance and measuring of your performance. There are two choices. You can be certified or you can be participating. To us, certifying was the only one that really made sense, because we've been dealing with people talking about it and making promises and pledges and all of that for pretty much all of our lifetime. We wanted to be able to prove it. And that independent third party verification is what it's all about. Again, robust metrics and improvement tools are plentiful and help you a great deal. And again, ISO 50001 is international, and anyone uh, can become part of it. And it lets us all know what we're talking about. For Harbec, it provided future focused marketing idea, potential. It provided carbon neutral precision manufacturing in metals and plastics components at no additional cost. It was our goal that we decided to make happen. And this was in pursuit of, again, European and Asian and other countries like that were doing a great deal with ESG reporting. Again, measured, proven um, outputs, and we wanted to have a system that, if ever challenged, we could prove what we meant when we were said we were carbon neutral. And then strategy grounded in performance and proof. That's the validation that comes from, in our opinion, SCP certified. Next, please. Energy savings and translate into revenue. These are along with the reporting of your energy. consumptions and reductions and all of that with ISO. You also have tools that teach you how much you're saving from a result of that, your economic impact. So their big thing is to try to get the eco-economic idea out to the business is. And as an example, for Harbec, as a platinum level, which is the highest level you could attain, uh, which we were certified at during all of our time involved in it. We 9% additional energy usage reduction since from 2016 to 2019. So it teaches you how to reduce your energy, and then uh, you turn that into the dollars saved. Global performance, Harbec was in 2019 the 16th highest energy reduction performance worldwide, which is pretty amazing for a small company, but shows that anybody can do it. Our financial impact, and this is what this point is all about, during that same period of time, from 13 to 19, we saved over $300,000, and it's all documented and proven by the ISO 50001 system. Why bother? $300,000 in savings at in our line of business, a 5% margin is doing pretty well. And so that same $300,000 positive impact on our business bottom line could have been attained by $6 million more in equivalent sales and effort. So there's another way to do it, but in our opinion, this was a better way. Next slide, please. Energy management strategy for then that was developed by us had three basic elements. It included combined heat and power, which reduced our energy costs by capturing the 65 to 75% of energy that is normally wasted. This point makes sense, and I've used it for every place I've talked for all these years, except in Quebec, because you have a way hugely disproportionate. God bless you, and you're so blessed to have it of wind and renewables. So you are the exception to the rule, but the majority of the reality is that a normal utility that's burning a fossil or nuclear fuel of some type is throwing away 65 to 75% of that energy before it gets to the customer. And if that seems completely unrealistic, it's because the majority of that is in waste and what they call wasted heat. From the running of the engines, generators, they are exhausting through usually water or air that thermal to keep their machines from burning up. That wasted, in our opinion, energy. Also takes more energy to push into the water or to the exhaust into the air. All that adds up to 65 to 75% of the whatever was in the fuel. You get to use 35 at your switch or 25%. On-site renewable generation is our second element, and it allows us to lock in our energy costs. So, unlike I said at the beginning, all we know about the utility is that our costs are going to go up. With renewable, we know that our costs are going to be fixed and that the sun or the wind is not going to charge us any more for the opportunities of energy that it affords us. Green power from the utility is what we use for our third element because of the desire for carbon neutral. So what we can't make ourselves, we pay extra to buy it from the utility, which by doing that, we are forcing the utility to go put in more percentage of renewable energy versus continuing to burn the nuclear or fossil fuels. Why bother in manufacturing sector in our area, at least? Energy is 4 to 8% total cost of doing business, and reducing this improves margins without raising prices. Next, please. So, what it looked like then in the 20 years of developing this idea? The initial the challenges during the late 90s were to try to put this all into an idea. We ran into early problems with engineering and concept development and bank financing. This was a completely different, unusual idea. There were no benchmarks to refer back to for the banks, so it took a lot to try to convince them. And then how it played out, our first project was a combined heat and wind project, launched in 2000, 2001. We unfortunately could not do the wind because we had to sacrifice it for the CHP. And the reason is involved, and there's a lot of detail about it in other presentations I've done in that, but it's simply put, we were duped by a brand new technology, which was called microturbines. And a lot of people were putting smoke and mirrors on about their capabilities and pricing. And when we finally went to order them, almost nobody could, and had used the economics to bank the project. We couldn't find them, but we finally did, but they were much more expensive than we had banked for. So we had to adjust and convince the bank that we would put the wind on hold for a while. Luckily, we could prove that it worked with the CHP. The economics were there. So in 2002 and 3, end of 2 and beginning of 3, we were able to put up our 250 kilowatt first wind turbine. In 2007, we did a lighting upgrade. At that time, high efficiency ballasts and T T T whatever light fluorescent tubes were coming on, and so we replaced the old sodium lamps and things like that that were the state of the art in the industry at that time with these new efficient opportunities. In 2008, our CHP project paid off. What does I mean by that is that we used our dollars that we would have purchased the electricity for and the heat energy and cooling energy for. Instead, we bought the ability to make the electricity and to do the heating and cooling. And so by offsetting the utilities expenses, we were able to buy the CHP system. In 2009, we did barrel. There'll be a lot more about that in a minute. 2009, we were able to do a barrel insulation project. Now we're learning things from others and becoming very much more sensitive about where can we save energy is not only about making it, and as details about that coming too. We had a wind turbine project paid off in 2010. So from that's about an 8 year period of time. Again, displacing the amount of energy we would have bought from the grid to use it to pay for the wind turbine. In 2012 and 13, because of that went so well, we elected to put up our second wind turbine. And in 2014, we did. Now the lighting has advanced even more, and LEDs are very reliable. They're coming out with warranties and guarantees and all the things that you need when you purchase that type of thing. And they came out with bulbs that didn't care whether you had a ballast or not. So we had all these other fixtures installed for our first project, and we did not have to tear them out or replace anything. We just had to replace the bulbs. And you'll see the economics of these projects. CHP system upgrade in 2015 and 16. Now the microturbines are becoming more and more advanced, more and more efficient. And NYSERDA, our local efficiency encouragement agency in New York, had an opportunity to upgrade CHP systems for thermal improvement, and we took advantage of that. In the world of manufacturing, compressed air is a huge waster, usually the hugest waster of energy, electricity, basically. And so we got on a project to revamp our compressed air system, greatly reducing electric consumption. Geothermal project in 200 or 2020, and future things that we have in mind that we had hoped to be able to do in 21 and beyond. Next, please. What does the CHP look like? In our first iteration, we had 25 natural gas fired 30 kilowatt capstone microturbines, and they delivered 500, 750 total kilowatts potential, but our maximum load was only 500. So we decided to add extra for the opportunities of redundancy and maintenance, and ability to grow as the business grew. The thermal advantage, heating, cooling delivered almost fuel free. What do I mean by that? Goes back to that. It isn't magic. It's that 65 to 75% that the normal fuel burning utilities are wasting as a form of waste heat. And in our opinion, it's only waste if you are foolish enough to do it. And we prove it in how we use it with our thermal awareness. And recovered thermal energy then is used to heat and cool. And this at the first level, our opportunity, we were able to heat and cool, air condition and heat 9,000 square feet. Our molding area had 25 injection molding machines, and also to heat and cool 17,000 other square feet of manufacturing tool room and warehouse. Financial impact on this, again, I mentioned earlier, 7 years we were able to pay it back with not buying the gas or the electricity to do our heating and air conditioning, instead using the thermal waste, I don't think so, from generating the electricity that we needed. Next, please. Uh, CHP upgrade that I mentioned, I sort of made a wonderful opportunity for us to improve our thermal efficiency from our combining power. So we kept 10 of the original C30s, added in 8 new C65s, which was the state of the art at that time, for a total of, that says 850, that's a mistake, 820 kilowatt total capacity. And again, our low average maximum load was 500 kilowatts. And so we had ability to have 320 of redundancy, but also at that time, we were gaining notoriety in our local economic development agency, and I were working together to create an entity called the Wayne Industrial Sustainability Park. We sit on the edge of a high-tech industrial park, and our goal was to build a microgrid through that using the success and examples of Harbec, but politically, eventually, it did not succeed. But that's the reason for the extra there. Thermal advantages, which is all about capture and reuse turbine exhaust. Now we're able to do heating and cooling for 26,000 square feet molding area as we growing the business, and manufacturing tool room and warehouse, and 20,000 square feet a new facility upgrade, which included 14,000 feet of shop space and 6,000 more feet of office space. So all of these improvements that were not only the ability to do that job, but in the way that we did the job, because that additional thermal efficiency allowed us to remove 8 natural gas furnaces, 8 5-ton air conditioning units, and 2 rooftop 20-ton air conditioning units. So at that point in time and forevermore, Harbec had no furnaces, no boilers, and no air conditioners, but used the absorption chillers, that blue device you see there in the center, and another one on the top right corner that basically use thermal energy to make cold water. The cold water becomes your air conditioning, and you'll see other examples of how we use that soon. Our electric from the renewable, pretty straightforward. The first one was a 250 kilowatt wind turbine. We aren't what you would call a Class A wind site, but we are Class 3 and which normally you wouldn't put a wind farm here, but because we're displacing retail, it allows us to have very cost-effective value for the less dynamic wind production or wind energy production. And it also coincidentally is less wear and tear on the machine because of that. So all in all, at that time we were paying 14 cents a kilowatt hour and therefore generated $45,000 offset of electrical costs. And we had originally planned 8 to 10 years ROI on a $400,000 project, but it ended up being less than 10 years. And that was because during that time our energy costs rose. And the thing about this is that as the utility energy costs rise, your ROI keeps getting shorter and shorter. And then the other advantages of ability to lock in on our energy costs is very significant to the bottom line. And then the resilience and cost control. When the grid goes out, we feel real bad about it, but with our combined heat power and renewable energy, we keep running. Next slide, please. Electricity number two. Basically all the same things I just said, except that we increased with the second one to an 850 kilowatt machine. And now in wind, everything is exponential. So if you double rotor diameter, double whatever, double height, all of those things are exponential. You get 4 times more from it. And so now we have the ability to do 1.5 megawatts plus or minus 10% per year offset. And that now our electric costs are up to 16 cents. And so the financial performance, 6 to 7 years ROI on a $2.1 million investment. The ROI accelerates. In other words, these gets shorter as the prices for the utilities rise. Long-term strategic enables predictability of more than 50, approximately 50, but even more of our energy costs, 20 to 25 years of stable forecast ability, energy pricing. Total energy on-site renewable is 50 to 60% between the two turbines. Next, please. We also have a green fleet. Wherever possible, we try to apply this carbon responsibility to our vehicles. But then the advantage of that is that we spend less money for our fuels. And of course, we produce less carbon emissions. And but those vehicles, we've learned by owning them and operating them for these years, also require significantly less maintenance. We don't have oil changes and as many, and all of brakes and all of those kinds of things. So there's an additional level of saving there. And just as a point of interest, as making the decisions about vehicles. So I've added on the bottom 1 gallon of gasoline equals 19 pounds of CO2 emissions, or 1 liter is 2.3 kilograms of CO2. So choosing your vehicle's mileage or type of fuel can be significant, even in a small company. Next. The biggest, let's say it this way, the greenest energy that exists of all possibilities is the negawatt, the watt you don't use. And that is really played out well in how we or anyone designs their facility. So we spent extra money in this addition that I mentioned earlier that we put up. but followed the guidance of lead in leadership in energy and environmental design. We aren't certified by them, but they have a wealth of knowledge that is public information, and we used it to understand opportunities. Those opportunities that we took advantage of were daylight gathering. If you notice the picture on the top, the lights that you see there are not the lights. If you look closely, the lights are in front of those bright spots and they're not turned on. And the reason why is those are skylights. So the free light from the outside, and also in our case, the most significant thing that our employees have positively commented about all of the things that we do. So they enjoy daylight all day long. In-floor radiant heating in the second picture you see there, a way to deliver our hot water from our combined heat and power system to heat the building floors. And of course, heat rises, so the rest of it is up to physics. And then high energy performance is the third slide. The walls of our facility are um, 3-inch thick structural insulated panels. So they are metal, completely wrapped around 3 inches of dense foam and completely self-supporting. And the financial benefits of these, again, by designing the facility for sustainability, energy consumption is reduced. And then the number one rule of conservation is sustainability. Please, next. Lighting system upgrades, I mentioned them earlier about the specifics. We changed out. The first project cost was $65,000. Reduced our lighting bills by 48% or $38,000. And our financial incentives from NYSERDA that I mentioned earlier. In this case, we got a $16,000 grant, and there was a federal tax credit at the time for 8,000. Um, and the result of that was 1.5 years to pay for the first lighting upgrade. Next, please. The second lighting upgrade was I mentioned earlier. All we really had to do was change the tubes. So we purchased 1,280 of the new style LED tubes, installed them for a price of $32,000. We got a grant from our utility on that one that paid for half of it. And in less than 1 year, we paid back that lighting improvement. And even we hadn't got the grant, it would only have been 2 years. And here's a important thing to mention. That $22,000 you see there, and every other number that I've given you so far and will going forward, after the 1 or 2 years, continues to hit our bottom line year after year after year after year. So it isn't like that it's just a one-time thing and it's over. We are paying $22,000 a year less for that lighting opportunity, $38,000 a year from the one before. And those numbers keep positively impacting our bottom line year after year after year. Next slide, please. Industrial efficiencies. These are more ways of learning how to save on energy consumption by the choices of the equipment that we use to manufacturing. We're an all electric injection molding company because electric molding machines use as much as 50% less energy than hydraulic machines. We were thermal energy utilization through our combined heat and power, but also that air conditioning that we produced as a result of it. A side benefit of that was that we reduced our moisture content, which was one of our greatest problems of quality, and was handled by, in the top picture you see there, desiccant cooling. And we reduced 75% of the energy required to do that by just having air conditioned air and removing the moisture that before it started. And then high efficiency motor controls, you learn about as you pursue energy saving ideas that soft starts, variable speed controls, all of those things are not only more energy efficient, but they're much kinder to your equipment instead of slamming them on and slamming them off as basic bare motors would do. Next, please. The final project that we did was our geothermal project, and we did that during COVID. We basically, you see one of the two rafts that we were able to build and have installed at the bottom of our rainwater retention pond that um, allowed us to sink them to the bottom of the pond and in short avoid 14 to $16,000 worth of costs of running electric chiller to support our manufacturing cooling requirements. Instead, we run the water to the pond and either dump heat in the winter or pull cool in the summer. And it's a very, very amazingly significant impact. Next, please. We also are water neutral. We learned this through our relationship with ISO 50001. And a few years into it, they also began to teach us about water importance. And while we are blessed with sitting on the greatest source of fresh water in the world on Lake Ontario, the rest of the world is not. So we tried to and learned from them ways to continue to reduce our city water usage. In this city water, by that I mean the water that we get from the water utility, and that's water that had a lot of energy put in it to get it to you. And so it's not, we do rainwater harvesting, and one of the reasons why is to reduce our amount of city water for non-potable requirements. Next, please. This is the big one. This is what it all boils down to. And the one thing I hope everybody gets out of this presentation that we learned over our 20-year experience. Everybody talks about things that they can't do anything about, like your taxes, your insurance, your rent, and your utility bills. Most business owners don't even pay much attention to them and often would ask me, why do I bother? When I'm losing my focus and all these kinds of things. But they do matter, and you can affect change in some of them, and specifically utility bills. And so if you use the idea of leveraging your consumption, you can look at your utility bill as an opportunity. If I took that amount of money and took it over the next 5 or 10 or 15 years, whatever, and bought a device that made the energy or conserved the energy versus consumed it, then and I paid for it by those same offsetting those dollars, as long as the device or the opportunity lasts even one day longer than the ROI period, I've won. But in fact, they last 10, 20 years or more beyond it. So the positive impact keeps coming back to your bottom line year after year. And so instead of only leaving you with a bill for spent electrons, leveraging consumption idea for our company at more than 3 megawatts at 14 cents, which is now, again, I mentioned uh, over 20 cents on average. It meant $420,000 in revenue, and that's only for our electricity. Next, please. Sensitizing stakeholders, just briefly, because I'm running out of time, was an effort to begin to, through encouraged through ISO 50001, let our customers know what we were doing without forcing it down their throat. So when we quoted jobs, we quoted time and material and offset of carbon. And it was easy for us to calculate that because we were keeping track of it all for ISO performance. Next, please. Beyond 2020, these were things that we had in our plan to continue to do long after COVID was over, and we continued to grow the business. You can read through those. They were all very reasonable, all bankable by offsetting our energy consumption dollars. We also dreamed about having real-time energy monitoring, which we could tie into our ERP system and kind of automate the whole thing, but never. We got halfway through it, developing the sensors we needed in that, but then the end came when in 2022 we sent or sold the company to a company called AdMan. Next, please. Key lessons to conclude from Harbec's journey. Sustainable manufacturing is first and foremost good business. Lowering energy cost and water and waste translates directly into margin, resilience, and competitive pricing. Treat mandatory energy costs, leveraging your consumption, as investment fuel for on-site energy and efficiency assets that pay you back every year. Instead of just buying the energy, buy the energy maker or the energy saver. Measured, verified performance that you get through things like I don't know of any other, but through certainly through ISO 50001 audits and real-time monitoring, turns sustainability claims into bankable proof for consumers or customers rather, and financiers, and a long-term roadmap of opportunities like CHP, solar and wind, energy efficiency, all electric molding equipment, geothermal, water neutrality, and all of these lets you sequence projects so each success can help fund the next project. And finally, a call to action for manufacturers. Start with your energy and water bills. Form a baseline. That's what you do, you learn through ISO. Set specific intensity targets per part, per machine, per dollar of sales, whatever is best for your type of company, and measure it responsibly or relentlessly. Design every new equipment and facility decision as an eco-economic opportunity. Insist on lower kilowatt per part, lower gallons per part, and documented life cycle savings. Build a cross-functional team. Operations, finance, maintenance, purchasing, and ESG, among others, to vet projects using total cost of ownership and risk, not just first cost. And often this is tied in with the idea of people, planet, profit. And finally, use Harbec's experience as proof that sustainable manufacturing companies can lead early movers in low carbon, resource efficient production will own the structural cost advantage for the next 20 years and beyond. And that's it. Thank you very much for your attention.
Thank you so much, Bob. That was really wonderful. I'm realizing because there's normally a Q&A or Q&R button at the end for people to provide questions, but for some reason it doesn't seem to be there. So, but there is a chat. So if there was any questions from the spectators, please type in your question. I'm really sorry, or perhaps show. I don't know if there's a way to show your hands, and I can give you maybe the possibility to speak because we're not too many people, so that's reasonable. But my question maybe for you, Bob, as I'm here, is because I mean, your company had the privilege of having the CEO being part of it. But what happens when a company is more directed by an external board or, how can you ensure that the values that you're putting forward can still go ahead or be part of the company's value when, let's say, the chief founder of the company is no longer part of it?
Unfortunately, you can't. Uh,
Yeah.
History has taught me a very important lesson that, and my case is the example. The new owners have nothing to do with it. There's complete everything I told you about is gone.
Hmm.
Everything. And
Yeah.
uh, and they are a mergers and acquisitions group who is focused on other things, primarily EBITDA, one myopic part of business, and that is the ultimate ruler for them. So they don't have the luxury that I had of long-term vision. If I hadn't got to 75 years old and hadn't tried several times to do employee buyouts and other things to have a succession plan, and then worked for 5 years to try to find the right company that would continue it, and
Mm.
ended up failing in the end because it was all not true. So there, I don't know. I'm doing this though for you because I'm trying wherever I can to get people to think the other way and to see that I am not a tree hugger, or even if I was, it doesn't matter. I'm trying to show people, and will continue as long as I get the opportunity, that there is an economic
Mhm.
opportunity in this. And if that's what you're about in business, and if you have long-term vision, that's the one missing part in a lot of businesses today. That I know how many times people said, I don't even know where I'm going to be in 3 to 5 years, much less 5 to 10 years. And I think, my God, I don't understand that. I don't know how you can be a business person and not be looking out 5, 10, 20 years into the future and planning on that, not just living month to month and watching my EBITDA number. That's too simple. And
Yeah, well, I think that I mean what I really appreciate of the of Harbec is how you don't see sort of sustainability as being a one-shot deal. Like, okay, let's replace an equipment or just get a grant for this and then it's done. Check. It's like it's a continuous process that actually, as you reap the benefits of one sustainable measure that from this savings, you can reinvest it and continuously be improving. And I think that's something that we in industry we don't tend to sort of value that continuous work. It's like performance isn't a one shot deal; it's something you do continuously. And I think that's what I get out most of your project. There's somebody I'll give him put the hands up. It's François Tardy. François,
Yes, hello. Can
hello.
I put my camera on?
Yes, yes, sure. Go
How do
ahead.
I?
I'm not sure
Yes,
how, but
me neither.
normally there should be a little thing says video, and you can.
Anyway, it doesn't matter. Thank you, Mr. Belford, for your presentation. I have a sort of a philosophical question for you. You mentioned that Quebec had an abundance of electrical energy, which is true. However, decades ago, it was decided that heating was going to be done through electrical energy. So we basically decommissioned all of our residential, or most of our residential gas heating systems. So I would be thinking, instead of degrading all the electrical energy we have to heat, wouldn't it be, do you think it would be a more efficient use if we basically shared that high level energy, which is electric, and prevented you from having to build, let's say our neighbors in the United States, from having to build more gas or thermal power plants to supply electricity?
I completely agree, and would love to have those microturbines replaced with um, heat pumps. And at home, everything I have, I live on a farm, and all my buildings are run by air-to-air heat pumps. So there's an amazingly efficient alternative. But again, I don't have 3 to 5 cents a kilowatt hour reality of like Quebec does. And so for our situation at that time, uh, we chose the combined heat and power, but certainly wherever possible, I agree. It can all be done with electricity, and things like air-to-air heat pumps are a perfect example of ways of doing it.
All right, thank you.
You're welcome.
Is there more questions? I'm really sorry. I don't know understand why the Q&R button isn't there, but if somebody else wants to speak, they're uh, more than, we're very happy to take questions. Otherwise, the recording will be available as well as the PowerPoint. So we're going to put that on our webpage and on our YouTube page, which can be reviewed. And the Bob's email address is there. So if you have a question, you can follow up directly with him at some other time. So I'm just going to check. I see there is a Q&R button. It was just hidden. Oh, somebody just says, what a great testimonial. Very inspiring. There you go, Bob.
Thank you.
You're inspiring Quebec, so that's good.
Thank you.
So, well, anyways, we're going to, I guess, end with this. And well, thank you so much, Bob, for sharing your wonderful experience. I think that there hopefully will be more industrial leaders like you. It makes me think also of Ray Anderson, that was with the Interface Carpets international company, also was another very inspirational industrial leader. So I think you're part of that, and I thank you very much for sharing your wisdom with us.
Thank you very much. It was a pleasure, and thank you for the opportunity to talk to people.
Okay, thank you. Thank you, everyone. Have a good day.
Bye.